Hello student. So this lecture we have already discussed about the solid state chemistry and their basics, that is what is matter, exists in three different states: solid, liquid, gaseous. Why matter exists in three different states: classification, crystalline, amorphous, solid, properties of crystalline and amorphous solids, then types of crystalline solids on the basis of their structure and applications, then classification of crystalline solid on the basis of type of molecule associate to form a crystalline compound called as molecular solid, ionic solid, metallic solid, covalent solid, and their individual examples. So now up to this we have only seen the basic concepts of the solid state. Now we will go to the micro level analysis of the crystalline compound. Here we explore the crystalline compounds, their properties, their constituent present in the crystalline compounds. In this slide, if you see, this is the crystalline compound, is the bulk of crystalline compound. If you explore this crystalline compound in microanalysis or under microscope, you can find a smallest part of the crystal. That is, we can say a single crystal, and this single crystal, that means we cannot divide this crystal into the next small crystalline unit, but this is smallest crystalline unit, or we can say it is the fundamental unit of the crystalline compounds, right? So this is called as unit cell. So before go to this micro analysis, in this unit cell or single crystal, you can able to find out the number of atoms present in the crystal, or how the crystal is developed and which type of crystal is formed. So first, unit cell, or we can say single crystal. This is the fundamental unit of crystalline substance. Our unit cell is the smallest repeating structural unit of the crystal, is called as unit cell. So if you study this unit cell, you can put this unit cell into the three coordinate axis. This is a schematic representation of unit cell. So before go study this unit cell or explore this unit cell or analysis of this unit cell, you can put this unit cell in the three coordinate axis. This unit cell has number of edges between, that is distance between the two phases, then number of edges, there will be 6 phases of the unit cell. So to characterize this unit cell, we have to assume some parameters, and these parameters we can find out the characteristic property of the unit cell. So these parameters are called as lattice parameter. That means the parameter which will be help to analyze the lattice, that means crystal. So these are the lattice parameter, that means the edge length, that is the distance between two faces, that is we can assume that is small a, b, c, these are the parameters, and the angle between the two edges or two phases, this angle is represented by a symbol alpha, beta, gamma, is called as lattice parameter. That means if you analyze this crystalline unit, you should assume this parameter, that is distance between the two faces or plane is represented as a, b, c, and the angle between the two plane or faces or edges we called as angle, that is edge angle, that is represented by alpha, beta, gamma. So before go to this actual analysis, so we have learned about some terminologies, that is space lattice. Lattice means simple crystal, the three-dimensional regular space occupied by the particles, that means atoms, ions and molecule, in a lattice or in a crystal is called as space lattice. That means the space occupied by the atoms or particle in the unit cell is called as lattice space. That means this space is called as lattice space. Next is a lattice point. That means the position occupied by the particles, and we know the particles, atoms, molecule or ions in a space lattice is called as lattice point. If you see the figure, this dark dots or spot is the particles, that means atoms present in the unit cell. These atoms occupied the space or point in a lattice is called as lattice point. Okay. Then types of unit cell. Types of unit cell. The scientists, those are studied the crystalline compound, are called as crystallographers. So the crystallographer first studied some crystalline compounds, and to find out the fundamental unit of the crystalline compound we called as unit cell, and this first find or first fundamental unit they have investigate or explore, they called as a primitive unit cell, right? Primitive unit cell. And afterward they have find out the unit cell or crystalline compounds made up from the non-primitive unit cells. So what is different between this unit cell is, primitive unit cell means the unit cell in which the particles are present at only at the corner of the cube. Suppose this is unit cell, the atoms are present at the corner of the unit cell, right? So this type of unit cell or crystalline compound having the fundamental unit is called as primitive unit cell. But they have also find out some unit cell or crystalline compound having fundamental units having higher density. That means the 1 kg of crystalline compound occupied the less volume of the uh, unit cell, that means less volume of the crystalline compounds. And we also find out some crystalline compound having different volumes with different weight, that means the density of the crystalline compound is more. So these lower volume or smaller volume or higher density crystalline compounds having the unit cells is called as non-primitive unit cell. That means the unit cell in which the particles are present at the corner as well as the some other positions of the unit cell or unit space or lattice space. These are called as non-primitive unit cell. There are three types of non-primitive unit cells. Let us see. First is body center unit cell. That means this unit cell contain the atoms or particle occupied at the corner, at the cube corner of the unit cell, but additional extra atoms is occupied at the center of the unit cell. That means body center unit cell. This type of unit cell you called as a body center unit cell, and in short we called as a BCC crystal, body center unit cell. Next is the unit cell contain the atoms present at the corner of the cube or unit cell, but additional atom is present at the each face, at center of the each face. That means top, bottom, front, back, left, right. There are 6 faces. That means at the center of each face one additional atom is present. That's why this type of unit cell is called as face center unit cell, or in short we called as a FCC unit cell, face center unit cell, FCC unit cell. So this is short form of face center unit cell. And third type of non-primitive unit cell is called as end center unit cell. That means the atoms are present at the each corner of the unit cell, but additional atom present at the two opposite phases, center of two opposite phases, that means bottom top, or left right, or front back. That means at every end of the end center, that means top and bottom, the center of this end of the unit cell, there will be additional atom is present. That's why this type of unit cell is called as end center unit cell, right? So this is a short form of this unit cell is ECC unit cell, that means end center unit cell. These are the two types of unit cell, that is primitive unit cell and non-primitive unit cell. So crystal system, that means if we consider the crystalline compound of the universe, first the crystallographer have identified the 7 crystalline compounds. That means the crystalline compounds having the 7 type of crystals. That means cubic unit cell, only primitive unit cell if you consider, that means simple unit cell. So cubic having uh, cubic structure, that is tetragonal structure, orthorhombic, hexagonal structure, and then monoclinic structure of the unit cell, then last is triclinic unit cell. If you see, there will be the change in the lattice parameter. If we find the changes in the lattice parameter, that means distance between the faces of the unit cell, or angle between the edges of the unit cell. So on the basis of faces, or faces length, or bond length, or bond angle, or we can say edge length or edge angle, these unit cell are primitive unit cell are classified into the 7 form, that means cubic, tetragonal, orthorhombic, hexagonal, monoclinic and triclinic. This is 7 basic crystal system, we call as a 7 basic crystal system on the basis of their lattice parameter, right? Here that first the edge length will be same, A is equal to B is equal to C. Then if you see the bond angle, that means the edge angle, alpha is equal to beta is equal to gamma is equal to 90 degree. The unit cell will be the simple cubic form. If you see the lattice parameter, if you slightly change, that means A is equal to B, B is not equal to C. Then angle alpha is equal to beta, beta is equal to gamma is equal to 90 degree. The unit cell is form is called as tetragonal. This is the structure of tetragonal. If you again change the lattice parameter, A is not equal to B, B is not equal to C, then alpha is equal to beta, beta is equal to gamma is equal to 90 degree, and this is 90 degree. Then the structure of the unit cell is orthorhombic. If you again change the lattice parameter, A is equal to B or B is not equal to C, alpha is equal to beta is equal to 90 degree, but gamma is equal to 120 degree, the resulting unit cell is a hexagonal structure. So next is A is equal to A is not equal to B, B is not equal to C. Then alpha is equal to gamma is equal to 90 degree, but beta is equal to 120 degree. So we get the unit cell we call as a monoclinic unit cell. And this is last triclinic. That means A is not equal to B, B is not equal to C. Alpha is not equal to beta, beta is not equal to gamma, or it is not equal to 90 degree. That means every angle will be changes. So whatever unit cell we find, that is called as triclinic. These are the 7 basic crystal unit cell. So initially crystallographer only find the 7 basic crystalline compounds, that is cubic, tetragonal, orthorhombic, hexagonal and monoclinic and triclinic. But afterward they have tried to study, explore the more crystalline compounds and find out the non-primitive unit cell. So what are the non-primitive unit cell? That is BCC, FCC and end center unit cell. On the basis of this, the unit cell again, that means the crystals again find out, crystalline compound again find out the sorry the crystalline compound again find out in simple cubic, uh, that is all lattice parameter will be the same. Alpha A is equal to beta, B is equal to C, alpha is equal to beta, beta is equal to gamma. So we get the simple cube. This is primitive unit cell. If you consider non-primitive unit cell, so simple cubic also form two additional non-primitive unit cell. That means BCC, body center unit cell, and face center unit cell. So next for trigonal, so we find a simple cube of trigonal, and this is non-primitive unit cell, that is BCC, tetragonal unit cell. Similarly, orthorhombic having also simple cube, then simple orthorhombic, then BCC orthorhombic, then FCC orthorhombic, and end center orthorhombic. In orthorhombic, there will be the four type of the unit cells. In hexagonal case, hexagonal, so there will be the only one unit cell. There will be non-primitive. There will be no non-primitive unit cell. Then trigonal. So there only simple unit trigonal. There will be no non-primitive unit cell. But in monoclinic, we find in monoclinic there will be the simple monoclinic unit cell and end center unit cell. And in case of triclinic, only simple triclinic unit cell. On the basis of this primitive and non-primitive unit cell, there will be the 14 crystalline forms of the unit cell, or 14 type of crystalline compound, that is 3 cubic, 2 tetragonal, 2 orthorhombic, 4 orthorhombic, then 1 hexagonal, 1 trigonal, 2 monoclinic, and 1 triclinic. There may be 14 crystalline compounds. There will be 14 crystalline compounds, and this will be discovered by the Bravis crystallographer. So these 14 crystalline compounds are called as Bravis 14 lattice, or Bravis 14 crystal. That means 1 4 crystals. So these are the possibilities of the crystalline compounds. But if you again consider, this is for your syllabus for 12, but if you consider the symmetry of the crystalline compounds, by considering symmetry of the crystalline compound, that means there will be three types of symmetry: center of symmetry, axis of symmetry, plane of symmetry. If you consider these symmetries, the maximum crystalline compound will be 230 crystal system. That means up to this situation in the universe, there will be maximum 230 type of crystalline compounds are there. You have chance to investigate more than 230 crystal in the crystalline compounds. To do the crystal engineering, you have to chance to discover the new crystal. So next point is the coordination number of the unit cell. So what is coordination number? In coordination chemistry, you find out there will be coordination compounds. So there will be ligands on the central metal atom. That means number of ligand covalently joined to the central metal atom we call as a coordination number. The similar case also in the crystalline compounds. That means the number of particular contact with each other within crystal lattice are called as coordination number of the crystal lattice. These are the coordination number for the this type of crystal. For simple primitive unit cell, simple cubic unit cell having 6 coordination number. If you see, so if this is a center atom, any atom, and these are the possibility to contact the neighbor atom, that means 6 atom is there. So the coordination number for simple cube will be 6. If you consider the second unit cell, body center unit cell, this one, that means BCC, that means non-primitive unit cell, this is. So there will be, if you consider this atom, for the coordination of this atom in BCC will be 8. That means this 4 atom and this 4 atom are directly joined to the or contact with these atoms. That's why the coordination number for the BCC unit cell or body center unit cell will be 8. Next is FCC, that is face center unit cell, having coordination number 12. That means 12 atoms are contact with the one single atom. Similarly, this atom also then mean 12 other atom will be contact with each other. That's why the coordination number for FCC unit cell, face center unit cell, will be 12. So here MCQ type of question will ask you for your CET exam. That means the coordination number of BCC unit cell will be dash dash, then that means 6. Coordination number of FCC unit cell or crystal compound is 12. Coordination number of simple primitive unit cell or cubic unit cell will be 6. So that we should know about the coordination number. Next is number of atoms per unit cell. That means there will be relation in crystalline compound. Number of atoms of the unit cell is equal to the volume of the unit cell. That means the total number of atoms present in one unit cell are also called as volume of the unit cell. That means if you find out the number of atoms in the unit cell, then we can able to determine the volume of the unit cell. So let us see one by one. Example, simple cube. In simple cube we know the all the atoms are present at the corner of the unit cell. That means number of atoms in the simple cube is there are 8 corner of the cube. Each corner contribute 1 by 8, 1 divided by 8 part of the atom contribute to the unit cell. So if you see the figure, that means this is a unit cell. So 1 by 8 part of the atoms are contribute to this unit cell, and other part for the upper unit cell. This is left unit cell, this is back unit cell, this is LHS unit cell, this is top unit cell, and this is down unit cell. That means if you cut the sphere into the same 8 part, and out of this one part will be contribute to the one single unit cell, right? So how we calculate? Therefore the number of atom present in the unit cell, 8 corner is there, and one corner contribute 1 by 8. So total number of atom present in the simple cube is 8 corner into 1 by 8. That means 1 by 8 atom will be contribute to the unit cell. That means is equal to 1. That means the number of atoms present in the simple unit cell will be 1. So according to this statement, that means total number of atom present in the one unit cell is also called as volume of the unit cell. Then simple, then volume of simple cubic unit cell will be the volume of one atom. Okay. So similarly, if you consider the second example, that is body center unit cell, right? Body center unit cell. There will be 8 corner. Each corner contribute 1 by 8 atom, and one whole atom are present at the center of the cube, right? If you see the figure, this 8 corner is there, 1 by 8 atoms are there, and one completely atom, full atom is placed at the center of the unit cell. That means center of the unit cell. So therefore the total number of atom in BCC, that is body center unit cell, will be 8 corner into 1 by 8 is equal to 1, and one completely atom present at the center of the unit cell. So this 1 plus 1 is equal to, that means the total number of atoms present in the BCC unit cell will be 2, right? So according to statement, volume of the BCC unit cell will be the volume of 2 atoms. Okay. Then third is FCC center unit cell. FCC center unit cell. So if you see the figure FCC, in this system 8 atoms at the 8 corner and 6 atom at the 6 faces. That means unit cell having 6 faces, top, bottom, front, back, left, right, 6 faces are there. Each corner contribute 1 by 8 atom at the each corner, and each face contribute 1 by 2 atom to the unit cell. If you see this is this phase. At the center of this phase one atom is there, but it is present at the phase. That's why half of the atom will be contribute to the other unit cell. If you consider this phase, so only half of the atom will be contribute to this unit cell, but half will be contribute to the other unit cell. So there will be 6 phases. That means 6 phases. Each phase contribute one half of the atom. So the total number of atom present in the FCC unit cell will be the, these are the corner, that is 8 corner into 1 by 8 plus 6 phases into each phase contribute one half, that means 6 into one half equal to 4. That means FCC unit cell having 4 number of atoms present in the FCC unit cell. So according to statement, the volume of FCC unit cell will be volume of 4 atom. Okay. So third one is end center unit cell. In this system, there will be 8 atom present at the 8 corner and 2 atoms present at the any two opposite faces of the unit cell, and at the face of the unit cell contribute one half atom, and at the corner 1 by 8 atom. So the total number of atom present in the ECC unit cell, that means end phase center unit cell, equal to the 8 into 1 by 8 plus 2 into 1 half. There will be 2 atom present in the end center unit cell. So according to statement, we can also define the volume of the ECC unit cell. That means volume of ECC unit cell will be the volume of 2 atoms. So here we'll stop. In next lecture we will see the packing efficiency. Once we can find out the volume of the unit cell, so we know the volume of the unit cell, that unit cell having the unit length, that is A, B, C. That means volume means length, width and height, right? So area is length into the height. So volume will be length, volume will be the height, length and width. So that means if the length is A, then volume of the unit cell will be A cube, A into A, that means A cube. Once you can find the volume of the unit cell, then we can able to find out the lattice parameter A, that means the distance between the two faces, and this distance between the two faces, that means the distance between the two atoms, that means the atoms are present at the each faces. That's why we can able to find out the bond length of the molecule from this calculation or from this information. So here we stop the lecture. Next lecture we will go for the packing efficiency of the crystalline compounds.